So, welcome to the, I think this is our sixth lecture, right? Uh, Sorry, fifth lecture. Welcome to the fifth lecture of our class, which is on virtual laboratory in chemical engineering. So, in today's class, we will be discussing further concept of flow measurements through various flow meters. So, last to last lecture, we studied various types of flow meters, and then we went deep into the derivations of orifice and venturi meter, right? સો આપણે એના ઇક્વેશન્સ ડિરાઈવ કર્યા હતા અને એના એક્સપેરિમેન્ટ્સ પણ કર્યા હતા. સો આજના લેક્ચરમાં બી એ આઈડિયાને કન્ટિન્યુ કરીશું અને આપણે ઓપન ચેનલમાં જે ફ્લો મેઝરમેન્ટ થાય છે સો પર્ટિક્યુલરલી વી નોચ અને રેક્ટેન્ગ્યુલર નોચ એના પર ફોકસ કરીને આપણે ડેરિવેશન્સ કરીશું એ ફ્લો મીટર્સ માટે પ્લસ એના એક્સપેરિમેન્ટ કરવાના છે. સો બિફોર આઈ સ્ટાર્ટ ટુડેઝ ક્લાસ, લાસ્ટ લેક્ચરમાંથી કોઈને કંઈ ડાઉટ છે, કોઈ ઇશ્યુ હોય, કોઈ બી એક્સપેરિમેન્ટ ટ્રાય કર્યો હોય અને કંઈ પ્રોબ્લેમ આવ્યો હોય. આઈ થિંક ઓરિફિસ એન્ડ વેન્ચુરી મીટરમાં ડેટા જનરેશનમાં ઇશ્યુ છે. સો ત્યાં સીડીની વેલ્યુ કોએફિશિયન્ટ ઓફ ડિસ્ચાર્જની વેલ્યુ હાઈ આવે છે. અપાર્ટ ફ્રોમ દેટ એની અધર ઇશ્યુઝ દેટ યુ ગાઈઝ હેવ ફેસ્ડ ઓર એવરીથિંગ ઇઝ ઓલ રાઇટ? So if you don't have any issues, then we will begin with today's class. Okay. So, aim of today's experiment is to understand the discharge through V notch and rectangular notch, and then we will be computing coefficient of discharge for both V notch and rectangular notch. Okay. So, જેવું last lecture માં discuss કરેલું, flow meters are device which are used to measure flow rates and flow quantities. So, be it be liquid, gas or vapor, જે આપણી પાઇપલાઇનમાં કે પ્રોસેસ પ્લાન્ટમાં ફ્લો થઈ રહ્યો છે લિક્વિડનો કે ગેસનો, એના મેઝરમેન્ટ માટે ડિફરન્ટ ફ્લો મીટર્સ યુઝ થાય છે. પર્પઝ શું છે ફ્લો મીટરનું? ટુ મોનિટર ધી ફ્લો. સો મોનિટરિંગ શાના માટે હોઈ શકે? ઇટ કુડ બી ફોર કોસ્ટિંગ, રાઈટ? અપાર્ટ ફ્રોમ કોસ્ટિંગ, જસ્ટ સ્મૂધ નોર્મલ ડે ટુ ડે સ્મૂથ પ્લાન્ટ ઓપરેશન માટે. ઓકે. એ સિવાય કંટ્રોલિંગ થઈ ગયું કે ઓપ્ટિમાઇઝેશન ઓફ ધી પ્રોસેસ. સો આ બધા પર્પઝ માટે વી નીડ ટુ મેજર ધી ફ્લો રેટ, રાઈટ? સો દેટ્સ વાય ડિફરન્ટ ફ્લો મીટર્સ આર યુઝડ, એન્ડ વી સ્ટડીડ ધી વેરિયસ ટાઈપ્સ ઓફ ફ્લો મીટર. સો ફ્લો મીટરના ટાઈપ્સ છે દેટ ઇઝ ડિફાઇન્ડ બેઝડ ઓન ધી વર્કિંગ પ્રિન્સિપલ ઓફ ધી ફ્લો મીટર. સો ઇટ કુડ બી ડિફરન્શિયલ પ્રેશર ફ્લો મીટર, જે આપણે લાસ્ટ ટાઈમ સ્ટડી કર્યા, જે આપણે ઓરિફિસ and venturi meter આ બેની સ્ટડી કરેલું, રાઈટ? અપાર્ટ ફ્રોમ દેટ દેર આર ટુ મેજર ફ્લો રેટ એક્યુરેટલી, જે માસ ફ્લો રેટ મેજર કરવા માટે વી સો ધીસ થર્મલ માસ ફ્લો મીટર, દેન કોરિયોલિસ માસ ફ્લો મીટર. ઓકે. દેર આર સમ નોન હિન્ડરિંગ ફ્લો મીટર્સ જેમાં કોઈ બી કમ્પોનન્ટ્સ ફ્લોમાં ઇન્ટ્રોડ્યુસ કરવામાં નથી આવતો, તો દે આર અલ્ટ્રાસોનિક એન્ડ મેગ્નેટિક, રાઈટ? Okay, then turbine vortex અથવા તો positive displacement, sorry not positive displacement but turbine અને vortex માં we insert external part within the flow to measure the flow rate, right? And then lastly open channel flow meter. So open channel flow meters, as we had discussed, is to use to measure the flow rate in the open channels. Okay, now selection criteria for this flow meter will depend upon our requirement, how much accuracy we want, what kind of service we have, okay, what kind of fluid properties we have, right? So this were the various criteria that we had already discussed last time. So I'm not going to the details of this. તમે પાછું આને એકવાર જોઈ શકો છો અને કોઈ ડાઉટ હોય તો you can ask me. Okay, so આપણે જે આજે ડિસ્કશન કરીશું that is open channel flow meters. Okay, so open channel flow metersમાં જે છે કે flow is measured in open channel like river or canal using vias or ultrasonic sensor. So આપણા આજના ડિસ્કશનમાં વિયર ટાઈપ ઓપન ફ્લો મીટર રહેશે. અલ્ટ્રાસોનિક સેન્સર્સ આર પ્રીટી સ્ટ્રેટ ફોરવર્ડ. it's like, so this is your open channel, there is one source, and then one source and then another receiver, right? So based on time travel अथवा तो diffraction pattern on the ultrasonograph, you decide कि flow rate કેટલો હશે, right? So that is very straightforward, but again this will be a kind of a expensive flow meter to measure flow for the open channels. Accuracy હોઈ શકે but stand still, and it's expensive. Plus to some places it might be get affected since it's ultrasound, so external environment factor in affect કરી શકે. So that's why weir type open channel flow meters are very commonly used, okay? And the use for this type of open channel flow meter is to measure the flow rate in water service or wastewater service. So advantage that you get is that they are very cheap, like economical, used for a larger flow rate and for a non-pressurized system. While disadvantage is that the flow rate calculation will depend on specific type of geometry, and for each you need to do some sort of a calibration, right? So open channel ma weir type ma the common two which we had seen last time, one is this V notch and another is rectangular notch. So not particular it exactly શું છે. So notch is a opening, you can see. So this is kind of a opening જે બી flow path માં છે, opening that is placed within our flow, our flow. So notch is a opening in the side of measuring tank, okay, or a reservoir extending above the surface, right? So these notches are placed are used to measure the discharge of open channel flow by placing them across the stream. So કોઈ બી સ્ટ્રીમમાં notches ને પ્લેસ કરવામાં આવશે so that we can measure the flow across them, right? So the use is either small open channels or laboratory part. So kya type ni notch hoy છે? So we have first triangular notch, so you can see એનો shape જે છે triangle type છે. Then rectangular notch માં બી we have further type. One, this is the suppressed rectangular, then there is this contracted rectangular. So difference શું છે? In a suppressed rectangular જે ફ્લોની વિડ્થ છે, ફ્લો ચેનલની વિડ્થ છે, અને જે વિયર છે they have same width, while the contracted rectangle માં you can see this is the total breadth B, અને જે L જે છે weir width, they are different. So weir width is less than the actual open channel width, right? So and the difference also, so difference will mainly come in the calculation part and then how flow measurement is done. So that we will look later further derivation part ma, okay? Then you have this trapezoidal or cipollati kind of notches, then step notch. So step notch you can consider as multiple rectangular notch, right? So step notch is nothing but a multiple rectangular notch. So it's combination of, like this is one rectangular, second rectangular and third rectangular. So each has some disadvantage, some advantage, okay? So we will come to that also. Now before starting the derivation part for V notch or rectangular notch, let's understand the flowing principle in this notch system. So there are two terms used, one is crest or seal and one is nap or vein. So what is crest? So let's look at the side view. જ્યારે flow થઈ રહ્યો છે, so let's say this is your flowing condition and I am looking at the cross section, okay, till R height સુધી initially we have some fluid, okay? Okay, this is your height where which is like bottom of your notch, okay? અત્યારે હું rectangular notch consider કરું છું. So what is crest? the bottom notch over which water flow is known as the crest. So crest will be જ્યારે water level will be close to the, will be exactly meet to the bottom of your notch. Okay, so this portion will be referred to as crest or seal. Okay, then nape or vein, the thin sheet of water flowing over the notch. So let's say initially water flow થાય છે ધીરે ધીરે we have placed this obstruction, water level will rise and it will come to this point. After that આના પછી જે water level હશે that will come here and then start to flow through this notch, right? So એ જે flow હશે that will be nape or vein. So the thin water flowing over the notch is known as nape or vein, right? Now so the edges of notch, this edges of this notch are beveled, એટલે bend કરેલી હોય છે on the downstream side to have a sharp edge side. Okay, and a crest resulting into the minimum contact with the flowing fluid. So the edges કઈ રીતે બનાવેલી હોય છે? Again, let's consider a cross sectional view. The edge of your notch is made such that કે જે water flow થશે ને, જે nap જે છે, nap will have a minimum contact. Sorry. Yeah. This nap layer or thin layer will have a minimum contact with your surface. Again, it's changing. Yeah. Understand? So this is your wall and nap. તો એજીસને એ રીતે શાર્પ કરેલી હોય so that it flows over the wall. વોલની સાથે સ્ટિક નહીં થતું. Why it should not stick to the wall, there is reason behind that also. So if you look the type of naps, that I will come in just a minute, different type of nap has an effect on the way we calculate the flow rate, right? Now how to calculate the flow rate? So flow rate in this notches is measured by the head over the notch. Okay, so the flow rate over the notch is measured by measuring the head acting over the notch. So basically we are saying height of the flow over the notch. So if this is the flow and this is the height, આપણે આ હાઇટને બેસિકલી રિલેટ કરીએ છીએ ફ્લો સાથે. ઓકે, so there will be flow proportional to height. We will get this sort of a relation. Okay, so discharge through a weir or notch is directly related to water depth. So this will be function, not exactly proportional to some power. Okay, so for rectangular notch it's 3/2 power, like for V notch it's 5/2. Okay, then the head is affected by the crest condition, the contraction, the velocity approaching to the stream, and the elevation of water surface downstream from the weir. So this basically means જ્યારે water, let's say this is the crest level. Okay, and then we have this nap. Okay, so the head is affected by crest condition, the contraction and the velocity of approaching stream, the elevation of water. So I wanted to say this, that there are types of nap. First is we have a free nap. Free nap meaning just first is free nap. ઓકે, સો ફ્રી નેપમાં શું થાય છે, જે આપણે પ્રીવિયસ ઇમેજ જોઈ, there will be this portion જ્યાં એર ટ્રેપ થયેલી હશે. Okay, so air circulation beneath the notch, beneath the nap and the wall is possible. Okay, so nap is detached from the wear height, like wear wall. Okay, so this is accurate. This helps for accurate. Sorry, again this should not happen. Accurate. So basically my laptop pen is not working, so I'm connecting through iPad, so slight navigation is difficult here. So accurate flow rate can be measured through this if nap has no contact with the wall. એના લીધે if contact નથી તો જે flow છે it won't be affected by the wall and fluid interaction, right? Then there is this second type of a nap which is called as depressed nap. So depressed nap or a clinch nap. Okay. So clinch meaning surface સાથે flow જે છે nap નો it's attached, right? So you will get this sort of a flow. કે જે flow જે છે there won't be no air present, right? If this occurs, so to say fluid will directly slide down from the weir to the surface, right? So because of that there won't be enough aeration, okay, because of which the flow that we are calculating will be affected, because now fluid will directly flow through the surface also, which we won't be able to account. The derivation that we will see works by assuming that there is this air gap in between, right? The velocity calculation that we will put during the derivation is assumes there is this air gap, and based on that we calculate the velocity. If flow will pass through the surface, if it will pass through this way, right, in that case that calculation won't hold true, right? So if you have a depressed or clinch nap, in that case you add air ventilation okay, so you add air ventilation hole, right? So the cross section ma just beside the weir we will add holes for air circulation, right? So that we get a free nap for the accurate flow calculation. Okay, so we understood that flow rate is related to height of the weir, and it has some relation, and then we will compute that relation, right? But this head is affected by crest condition, the contraction. So contraction part I will come in the rectangular notch. So જ્યારે flow જે છે weir માંથી પાસ થાય છે, so this end point, this edges, okay, edges આગળ જે flow છે that will also be get affected by the shape of edge. Okay, so એના લીધે contraction પણ create થતા હોય છે, right? So જે contraction છે that is related to your shape of weir, particularly in the rectangular case where we have different type of rectangular notches, ત્યાં આગળ contraction important બની જશે. So this sort of a parameters are will be considered during the derivation part, which we have to account, right? So let's move forward with the first notch type flow meter, okay, that is V notch. Oh, sorry, there was this another type I forgot. So this is one type of nap. This is second type, and then we have third type, which is submerged nap. So as its name says that nap જે છે એ submerged થઈ ગઈ છે. So in that case that shows that flow rate is too much. So either we have to reduce the flow rate or change the height of the crest so that જે nap જે છે that is still at a higher elevation from the further downstream layer. Okay. So you can imagine it this way કે આ જે ફ્લો જે છે વોટર લેવલ બોટમમાં અહીંયા આગળ હાઈ છે, રાઈટ. So because of that nap is submerged, right? So this is a submerged nap. So in that case what we have to do, we have to reduce the flow. If we have a control over flow, right, else we will change the height of the weir, right, so that we have a free nap. Okay, so this is one thing you have to be careful, because all this this depressed or a submerged nap will affect your flow rate calculation. Okay, so let's move forward with the V notch. In the V notch we have this V shaped triangular shaped notch, right? So let's the angle that we use, this theta angle. So generally there are different angles possible. So 90-degree angle is widely used, it's standard. Then you can have a smaller V notch which has a 60 angle, and then a wider V notch which will have a higher angle of 120 degrees centigrade, right? So it's basically triangular shaped notch placed in between of your open channel. Advantage is that but it gives you higher accuracy, particularly at the lower flow rates, right? But it's sensitive, since it's sensitive to small changes. We will come to that also, right? So when you will derive, we will find that flow rate is proportional to the 5 to the power 2, 5 by 2. So it's like 2.5 times the power of head. Our flow rate is proportional. So head માં આપણે થોડો બી changes કરીશું તો flow rate it will be reflected in the flow rate, right? Okay, so small sensitive to small changes in the head. It's self cleaning, so less prone to debris and clogging, simple, inexpensive, but it's not suitable for a higher flow rate. Okay, then the issue of submerging will come. So in that case we will use rectangular notch, which is suitable for a higher flow rate. Then it requires a free flow condition. Downstream water level must not affect the head, which we have already discussed. આપણે discuss કરી લીધું છે, right? So let's try to derive this. અહીંયા ગડી. So this is our total height, જે flowની height છે through V notch, એ total height h છે. Now જે આપણે height measure કરીએ છે ને, so that height is measured from the reference level of our crest. Okay, so crest ની height will be our reference point. એનાથી ઉપર જેટલી બી નેપની હાઇટ હશે, that is our height h. Okay, so h જે છે it's total height. Okay, this is with respect to crest. Okay, just remember this height is with respect to crest. એના ઉપર જે બી હાઈટ હશે આપણે નોચ નેપની હાઇટ કન્સિડર કરીશું, નોચની હાઇટ કન્સિડર કરીશું, રાઈટ? નાઉ theta is the angle of notch. So let's consider this small element, okay, of dh height. Okay, right? So આ સ્ટ્રીપને કન્સિડર કરીએ આપણે કેલ્ક્યુલેશન્સ માટે. So if I want to find the width if I want to find this width, then I can use the geometry and calculate the total width, right? So if I want to do total width, W, again sorry, it's not working well. Okay. So let's say I want to compute this width. So width, I'm saying total width W will be, so this is our angle theta by 2, right? Total height h, and then I want to compute this will be W by 2, right? So W2 so say 2 times, let's use tan theta. So tan theta is tan theta will be W by 2 divided by h, right? So W by 2 will be 2 times W by 2 will be h times tan theta by 2. So therefore W is tan theta by 2. Okay, so this is one point. So this is total width. But when we will consider this strip, okay, a strip ne consider kariye, so in that case what will be the height, what will be the width? So width of the strip, width of strip, so equation same રહેશે, but instead of h જે આપણે total height consider કરીએ છે, it will be if top માંથી smallest જેટલા distance છે, so it will become 2 times h minus h into tan theta by 2. Okay, so strip no area જે છે that will become width into આપણી આ જે strip ની width height જે છે dh વાળી a, so that will become 2 times tan theta by 2 into dh. Okay, હવે if you we learned Bernoulli's principle also in last lecture માં Bernoulli's principle કરેલું, right? So if Bernoulli's principle આપણે apply કરીએ for a fluid at a height h, stationary fluid at a height h, and if it passes through a hole, right, then if you will apply Bernoulli's principle and they calculate the velocity of that flow, which will be kind of a nap in our case, right? So it generally so આવતું હોય છે √2gh, right? If you will see if it's at atmospheric pressure at height h, so Bernoulli's principle માં 0.1 પર we will have height h, and right hand side પર આપણી પાસે હશે kinetic energy v² by 2g. so generally જે velocity આવશે એ હોય છે √2dh. જે આપણે I guess it's very basic example, so I'm not deriving it, but if I want to compute, then flow through strip is √2gh, right? So this comes from the Bernoulli's principle. તો આપણને flow rate ખબર છે, so this is flow rate or velocity, you can say flow or velocity therefore flow rate dq જે સ્ટ્રીપમાંથી ફ્લો રેટ છે that will become your area into dv જે વેલોસિટી જે છે right area into dv just give me a minute. Just give me a minute to it's stuck again. It's not showing me. Yeah. Hmm. So आपने dq derive कर लीजिए flow rate through that particular stream. So that dq is area जो area आपका શું હતો 2 times this tan theta by 2 okay into your dh and then velocity आपकी શું आई root 2 gh okay so this is velocity flow rate through that particular stream but आपने total flow જોઈએ so total flow that will integration of this small dq from 0 to h height right and જ્યારે તમે integration કરશો so mainly you will have 2 tan theta by 2 will be out root 2g will be out then you will have integration 0 to h of h into root h minus h raised to 3 by 2 dh okay अंदर में इंटीग्रेशन કરીને ફર્ધર સ્ટેપને સિમ્પ્લિફાય કરશો સો જે ફ્લો રેટ પર તમે આવશો દેટ વિલ બી 8 by 15 જસ્ટ એક બે સ્ટેપ છે જે હું સ્કીપ કરી દઉં છું. √2g into tan theta by 2 h raised to 5 by 2. Okay, so this is the flow rate, but this flow rate is theoretical, right? And we'll learn last time also, due to the friction losses the actual flow rate will be different. So આપણે q actual જે compute કરતા હોઈએ છે, that will be coefficient of discharge into q theoretical, right? So coefficient of discharge is ratio of actual flow rate to theoretical flow rate. આપણી પાસે theoretical નું equation છે, so actual flow rate will be coefficient of discharge times the theoretical flow rate, right? So this is how you calculate flow rate in the V naught. Now આપણે આ further equation ને simplify કરી શકીએ. So if the angle of your V naught is fixed, if you know that, then this all part is constant, right? So let's say આપણી પાસે 90 degree નો angle છે, then you put 1045 and then G ની value 9.81. So you will get Q theoretical as this will simplify and come as 1.141, right? Not Q theoretical, sorry, Q actual will come as 1.417 h raised to 2.5. Okay, here I have considered coefficient of discharge as 0.6, right? So you can simplify this equation for your system also if you know the angle and if you know the coefficient of discharge. So CD value for the V naught is generally around 0.6. So it will change from 0.58 to 0.62. Okay. Then next we have a rectangular notch. So rectangular notch, as name says कि जे notch type છે rectangular છે. Now એમાં બી further type છે. So જે edges of the notch છે, right, crest પાસે, this edge and notch નો જે shape છે એના according આપણે further division થશે. One is fully contracted rectangular notch. So એમાં શું થાય છે कि your rectangular notch width is less than your total width of your flow. Okay, so this as an example છે, that is fully contracted rectangular notch. So in that case this is total height of your total width of your flow, total width of your channel, અને આ જે L જે છે that is your wear width, rectangular notch width, right? So when we have fully contracted rectangular notch, so length L in this case is less than W, right? See, is easily image પરથી બી clear છે, right? When we have both L equal to B, then we will have uncontracted notch, that is L equal to B. So width of your notch is equal to width of your channel. તો એનામાં કોઈ contraction નહીં આવે. Contraction નો meaning શું છે? So basically contraction is when fluid is passing through these edges. જ્યારે flow pass થાય છે small channel opening માંથી, so જે edges છે ત્યાં આગળ flow rate will be affected. Okay, so if you have a suppressed notch, rectangular notch, in that case you won't have this sort of a corner, તો ત્યાં આગળ fluid flow affect નહીં થાય. But if you have a fully contracted rectangular weir, right, so in that case જે flow pass થાય છે અહીંયા આગળ, there will be some dead zones. Okay, so when we will compute the flow rate, જ્યારે આપણે flow rate compute કરીશું rectangular notches માટે, then we have to account that actual width જે છે is not L but rather than આપણે આ જે dead zone છે એને બી compensate કરવું પડશે જ્યારે calculationમાં. Then we will come further also. Then you have partially contracted rectangular notch, and then Cipollati weir, which is like a trapezoid kind of a weir, right? So this way, trapezoid weir, अथवा तो यहाँ second name भी use करवाना आवे छे, right? So since it's trapezoidal type, So it will eliminate this contraction. જે સાઈડના corner points પર dead zone છે, it will eliminate, right? And then you have partially contracted, which is somewhere in between fully and suppressed contracted. So advantage શું છે? V notch, we understand that it is accurate, but then it's limited to the lower flow rate. So rectangular notch a limitation ને overcome કરે છે, and it's good for the higher flow rates, easy to install and construct, widely used in industry. Disadvantage શું છે? So it's not very well suited for a lower flow rate, right? So for lower flow rate, after V notch will give you the better accuracy, and sensitive to approach velocity. So requires steering basin of accurate reading. So again, this is related to your this nap formation and the crest height and the nap formation, right? So these things are related. So let's do the derivation for this also, and then we will come to this part કે જે આ contraction ને કઈ રીતે consider કરવાનું calculations માં. So rectangular notch માં let's consider this small strip, right? And it DH લખ્યું છે. Let's consider is it as a DH height, total height of your let's say flow જે છે total height h છે flow ની, right? Okay, and also this is h. આપણે DH element લીધો છે અને જે notch ની width છે, okay, initially આપણે consider કરીશું L is equal to V, એટલે total જે channel ની width અને notch ની width same છે, right? So if I assume this strip, તો strip નો area શું થયો? Area of strip, straightforward, it's a rectangle, so DH into your B, right? Then flow through this velocity dV will be under root 2gh. Again, this will come from Bernoulli's equation. So flow rate je dq છે, dq from strip will be area into your velocity, right? So dh into b into root 2gh, okay? So this is flow rate. Now total flow rate q શું થશે? Integration over total height, okay? 0 to total h વચ્ચે જે આપણે integration કરીશું, that will give you the total flow rate q theoretical. So this is integration from 0 to h over dq, okay? And when you will do this integration, so again same simple steps, right? So you will come to the value of q theoretical as 2/3 of b times under root 2g into h raised to 3/2, okay? So यहाँ कड़ी height ની power ની 3/2 proportional છે theoretical flow rate. So actual flow rate will be coefficient of discharge time theoretical flow rate, right? Therefore q actual, that will be CD into q theoretical, okay? CD value for rectangular notch also is somewhere around 0.6, okay? Now આપણે જે કીધું કે V notch is much sensitive to the height, because V notch માં if you will see the h value, okay, so flow rate q is proportional to h to the power 5/2, while here flow rate is proportional to h to the power 3/2, okay? So that's why V notch is particularly sensitive to the smaller height, so it gives a better accuracy, particularly at the lower flow rate, while for the higher flow rate rectangular notch is preferred. Now coming to the part where we said that different types of rectangular notch, okay? So what is this contraction and how to include it in our equation? So for that, So the first we considered a fully contracted rectangular notch. Fully contracted. તો એમાં જે length of our weir is less than channel length, right? And generally there are two corners, so water contracts at the side. So side na je corner points છે એમાંથી water contract થશે and bottom, so it flows through. જ્યારે weir through pass થશે ત્યારે એ portion માંથી there will be some dead zone. So total જે length હશે, this won't be exactly L, but rather L minus some portion, right? So L minus to something. So to account for that, જે આપણું આ Q નું equation છે, right? So અહીંયા આગળ આપણે B use કર્યું છે. Rest of the term same છે. So let's say, so instead of B, we will use L minus 0.2 times H. Okay, we won't go into the derivation part I came through, but instead of B you have to use this, and then rest of the term will remain same. Okay, so this is the rest of the term, but instead of B you have to use like weir width minus that dead zone part. Then you have suppressed or uncontracted weir, right? So in that case, suppressed weir માં your length of your weir, the width of the weir is equal to the width of your channel. Okay, so the Q na equation ma we can directly use L and then your rest of the term. Okay, I agree, no contraction. Then if you have a partial contraction, so in that case, instead of L, again length of L not length but width of your weir is less than the width of your channel. So આપણે એને account કરવા માટે there is this term L minus K times N times H, and then again your rest of the term. Okay, so here also L is less than B. So N is number of contraction, કેટલા point પાસે you will get this flow contraction, and your K is contraction coefficient. Okay, so it's coefficient, right? And then trapezoid ma again you can use this fully not fully contracted, but this one. So suppressed, and since trapezoid ma bhi koi contraction thatu nathi, so then you can use directly width of your weir L in your equation. Okay, so this was the derivation part. Now we will move towards the virtual lab part, જ્યાં આપણે virtual lab માં કઈ રીતે એનો એક્સપેરિમેન્ટ કરવાનું છે ને actual experiment setup કઈ રીતે હશે એ ડિસ્કસ કરી લઈએ. So if any of you have doubt કે આ ડેરિવેશનમાં કઈ doubt હોય તો you can ask, or I will move towards the experiment part. Any doubt? If not, then let's move towards the experiment part. Okay, so first is calibration of V notch. So all the derivations that we have done is also given here, you can check. Then let's look at the actual experiment setup ડેમોન્સ્ટ્રેશન એન્ડ દેન આપણે પછી વર્ચ્યુઅલ લેબમાં એકવાર એને પરફોર્મ કરી લઈશું.
This is the experimental setup of V-notch. Object of this experiment is to determine the coefficient of discharge of a V-notch. After switching on the pump, now open the inlet valve slowly. Let the water fill the channel up to the crest level.
So you can see જ્યારે crest is like lowest bottom of your notch, right? So till this level you will consider it as a crest. So initially આપણે water fill કરવાનું છે ચેનલમાં અને એને crest level સુધી લાવવાનું છે. Okay.
Now adjust the hook gauge to obtain a head of water. Open the inlet.
So જ્યારે level આવી ગયો, then we will measure the height of our crest.
Inlet valve completely. Adjust the knob of hook gauge to change the water level.
So hook notch થી આપણે level measure કર્યું, so that will be our reference point. અને further flow measure કરવા માટે એની above જેટલી બી height હશે flow ની, okay, that we will consider.
The difference between final water level and the initial water level gives the head of water. Calculate theoretical discharge of the notch.
Okay. So initial જે crest level આપણે note કર્યું, then flow વધારીને final reading લીધું, and difference of that will give you the height of water flowing over your notch, right? અહીંયા આગળ V notch માં. And then we will use our equation of V notch to calculate the theoretical flow rate.
Close the storage tank valve.
Now
To record the time taken by water to fill 10 cm height. Note down the value.
So આપણે અહીંયા આગળ શું કરી રહ્યા છે કે first we computed theoretical flow rate through V notch equation, then હવે આપણે actual flow rate બી કેટલો છે એ બી compute કરવો છે. So actual flow rate computation માટે આપણે ટેન્કમાં so there is this tank of known area, એમાં 10 cm height માટે કેટલો ટાઈમ લાગ્યો એ compute કરીશું. So volume divided by time, that will give you us, and then that will give you the actual flow rate, and then આપણે coefficient of discharge compute કરીશું.
Measure length and breadth of the collecting tank and calculate actual discharge of V notch, and also we can determine coefficient of discharge for this trial.
So equation પરથી આપણને જે flow rate મળ્યું, if we don't include coefficient of discharge, એ theoretical flow rate છે, જે that doesn't account any friction into the system, right? But જો આપણે friction ને consider કરીશું તો actual flow rate જે છે એ ઓછો આવવાનો છે. So આપણે actual flow rate બી compute કર્યું એક ટેન્કમાં x like certain volume ભરવા માટે કેટલો ટાઈમ લાગે છે એના પરથી, તો એ that is actual flow rate, and then coefficient of discharge is ratio of actual to theoretical flow rate.
Repeat the same procedure for other trial. Calculate the.
Okay. So this is the setup for V notch. Similar setup is for rectangular notch. We will look into that also. So not simulation.
Calibration of rectangle.
So here in this experiment આ લોકોએ શું કર્યું છે, rectangular notch plus V notch ને combine કરીને એક
Rectangular notch.
right? So first જે water flow છે એ rectangular notch માંથી જશે, and then it will pass through the V notch, અને આપણે બંને માટે flow rate compute કર્યો છે. Okay.
Objective of this experiment is to determine the coefficient of discharge of rectangular notch. This is the experimental setup. After switching on the pump, now open the inlet valve slowly to let the water fill the channel up to the crest level.
Okay. So this is now this type of, so this is contracted rectangular notch, right? So यहाँ कड़ी edges पर जैसे flow will be affected, right? So if the width છે will completely channel height જેટલી હતી, so then we can call it as suppressed notch. એકવાર ક્રેશ લેવલ આવી ગયું તો આપણે એને રેફરન્સ તરીકે કન્સિડર કરીશું. સો અહીંયા આગળ શું થાય છે, ફર્સ્ટ રેક્ટેન્ગ્યુલર નોચમાંથી ફ્લુઇડ પાસ થાય છે એન્ડ દેન વી નોચ ચેનલમાં જાય છે. ઓકે, સો ધીસ ઇઝ rectangular notch and then V notch.
The difference between final water level and initial water level gives the head of water. Calculate theoretical discharge of the rectangular notch. Now, adjust the hook gauge to obtain a head of the water over the rectangular notch. Open the inlet valve completely and adjust the knob of hook gauge to changed water level. Close the storage tank valve. Again adjust the knob of hook gauge over the notch to obtain changed water level. Calculate head of water and actual discharge. We can obtain coefficient of discharge for this trial. Repeat the same procedure for other trials and calculate the average coefficient of discharge.
So let's go and perform the experiment first. So first આપણે V notch નો experiment કરીશું. કેલ્ક્યુલેશન્સમાં એક્સપેરિમેન્ટમાં કંઈ છે નહીં, ઇટ્સ વેરી સ્ટ્રેટ ફોરવર્ડ એન્ડ સિમ્યુલેશનમાં જ રિઝલ્ટ્સ કમ્પ્યુટ થઈને આવે છે. સો ગો ટુ ધી સિમ્યુલેશન પાર્ટ, રાઈટ? ઇટ્સ ઇન્ટરેક્ટિવ કાઇન્ડ ઓફ અ સિસ્ટમ. સો વી હેવ કમ્પ્લીટ ચેનલ વી નોચ અને એન્ડમાં કલેક્ટિંગ ટેન્ક છે જ્યાંથી આપણે એકચ્યુઅલ ફ્લો રેટ મેજર કરીશું. પ્રેસ નેક્સ્ટ. સ્ટેપ્સ બી અહીંયા લખેલા છે. સ્ટેપ 1, સ્ટાર્ટ ધી પમ્પ બાય પ્રેસિંગ start button, and જે મારું માઉસનું કર્સર છે ત્યાં આગળ you can see there is this hand, right? So press this green button. I think its location is, let me reload it. Okay, so once pump is started, then next steps પર જવાનો ઓપ્શન આવશે. Go to next step. Open the valve. હવે ઇનિશિયલ વોટર લેવલ ઓલરેડી આપણી પાસે ડિફાઇન્ડ હશે, જે ઇનિશિયલી સેટ કરેલું હશે. દેન જ્યારે નવા ફ્લો રેટ માટે હાઇટ અગેન ચેન્જ થશે તો આપણે ફરીથી વોટર લેવલની હાઇટ લઈશું. એન્ડ દેન ડિફરન્સ ઓફ ધીસ ટુ, દેટ વિલ બી આર એચ, રાઈટ? સો અહીંયા આગળ 10.04 minus 3.15. So that is 6.89. So this is our head of water. Now V naught છે તો V naught માટે આપણે equation derive કર્યું. So Q theoretical is 8/15 under root Tg, 2 times gravitational constant into tan theta by 2 અને h raised to 5/2. Additional parameter શું છે તો અહીંયા આગળ G ની વેલ્યુ અને એંગલ વેલ્યુ આપેલી છે, રાઈટ? So if you want to compute, so this will come somewhere around 5/2 into 8/15 into 2.8 1 into 1045. Answer 10. So 29437, somewhere around that value. So you enter this value. So this is cubic meter cube, not meter cube, sorry, cubic centimeter cube, and then per second. Okay, just check your value. If તમારો આન્સરમાં કંઈ મિસ્ટેક હશે તો બે વાર ચેક કરવાનો ઓપ્શન મળશે, then you can see the direct result. So just digitમાં error હતી, બાકી આપણો આન્સર આવશે 2943.7, right? This much centimeter cube per second. So this ફોર્મ્યુલામાં તમે h ની વેલ્યુ પુટ કરશો અને કમ્પ્યુટ કરશો, so you will get this value. Then so this is આપણે theoretical flow rate calculate કર્યું. હવે actual flow rate આપણે આ ટેન્કમાં વોટર લેવલ સર્ટેન વોલ્યુમ મેજર કરીને કન્સિડર કરીશું. તો વાલ ક્લોઝ કર્યો સો દેટ ટેન્કમાં લેવલ ભરાય. 10 સેન્ટીમીટર હાઈટ ભરવા માટે કેટલો ટાઈમ લાગ્યો? તો એ 20 સેકન્ડ છે, રાઈટ? હવે એકચ્યુઅલ ફ્લો રેટ શું છે? તો ટેન્કનો એરિયા ઇન્ટુ એની હાઈટ એટલું વોલ્યુમ ડિવાઇડેડ બાય 10. સો એરિયા આપ્યો છે આપણને 3500 ઇન્ટુ હાઈટ જે છે 10 સેન્ટીમીટર. ઓકે, એ 20 સેકન્ડમાં ભરાવો. સો ફ્લો રેટ ઇઝ 1750, રાઈટ? તો આ એકચ્યુઅલ ફ્લો રેટ હોય. તો હવે કોએફિશિયન્ટ ઓફ ડિસ્ચાર્જ શું થયું? એકચ્યુઅલ ફ્લો રેટ ડિવાઇડેડ બાય થિયોરેટિકલ ફ્લો રેટ. So if you will do that, just like 0.59 and check. So આ થયું. So this is one trial. Same अलग अलग flow rate पर simulation માં experiment repeat થાય છે, and at the end you will get this flow rate versus head. એનો એક plot પણ બનાવી શકશો. So I will just skip this all step, like same step repeat થાય છે, just अलग अलग flow rates માટે. Just putting random value, so આગળ આપણે સ્ટેપમાં જઈ શકીએ. Then so I'm just putting random value, and you will do just calculate it properly, right? And I get coefficient of discharge higher 0.65. Okay. Then third trial, again same step repeat hase. So you so once you do this, stop the pump, and then if you have multiple data, then you can plot actual discharge versus head no plot. Now the normal આપણો discharge છે, like theoretical flow rate, that varies with h to the power 5/3, right? And આ log plot છે. So if you will find the slope, it should come somewhere around 5/2, right? So 2.5 ના around slope આવવો જોઈએ, અને જે intercept હશે એ તમને like lowest value આપશે, right? So slope જે છે ગ્રાફનો somewhere around આવે છે 2.45, right? So ideally it should be 2.5, but our actual flow rate છે, so that will vary slightly from, so relation will vary slightly from the theoretical value, right? Then coefficient of discharge ની value compute થઈ છે, average value છે. So you can take multiple readings and average out your value, right? So this is calibration of V notch. Now similarly we can look for the calibration of rectangular notch. Same sort of experiment repeat થશે. So અહીંયા આગળ first flow will pass through rectangular notch and then V notch, right? So apparatus you can see rectangular notch, V notch, hook gauge, measuring scale, etc. start the pump. If simulation properly work ના કરે, જેમ કે અહીંયા આગળ ક્લિક નહીં થતું, just restart it and then do it. It's not working. Once this is done, so first open the inlet valve and allow water to fill to the crest level, right? Crest level note kar lidu. Now initial reading water level till crest noted. Then theoretical discharge over rectangular notch calculate करी, तो higher flow rate पर height difference, so 9.16 minus 4.6, so that is 4.56. આટલું આપણું વોટર લેવલ થયું રેક્ટેન્ગ્યુલર નોચમાં, રાઈટ. નેપ હાઇટ જે છે, રાઈટ. હવે ક્યુ થિયોરેટિકલ ફર્ધર સેમ ડેરિવેશન પરથી યુ કેન કમ્પ્યુટ. નાવ અહીંયા આગળ જો સિન્સ ઇટ્સ અ ફૂલ્લી કોન્ટ્રાક્ટેડ રેક્ટેન્ગ્યુલર નોચ, સો ફૂલ્લી રેક્ટેન્ગ્યુલર કોન્ટ્રાક્ટેડ નોચમાં આપણે શું હતું કે L માઇનસ 0.2 ટાઈમ્સ હાઇટ રાખેલી. અહીંયા આગળ એડિશનલ પેરામીટરમાં ઇફ યુ વિલ સી નંબર ઓફ એન્ડ કોન્ટ્રાક્શન છે 2, તો ઇક્વેશનમાં ઇફ યુ વિલ પુટ n ઇક્વલ ટુ 2 into 0.1, so that will become L minus 0.2 times h, which is fully contracted rectangular notch, right? So instead of total width height આપણે લેવું પડશે L minus 2h. લેન્થ ઓફ રેક્ટેન્ગ્યુલર નોચ અથવા વિડ્થ જે છે એ આપી છે 15.1 minus, if you will do this, just you can also calculate it with me, 4.56, right, into 4.56 raised to 1.5 into 2 by 3 under root 2. So 4079.68. Just check this value. No, 69 round off करेलू છે, right? So this is Q theoretical. Now once rectangular notch માં pass થઈને આવ્યું, હવે further they are also measuring the discharge through V notch also. Okay, so એના માટે V notch ની height વી નોચમાં ક્રેસ્ટ લેવલ રેફરન્સથી નેપની હાઇટ કેટલી છે એ કમ્પ્યુટ કરી, એન્ડ દેન યુ કેન પુટ ધીસ ડિફરન્સ 13.64 minus 5.87, which is 7.77. You check it. Now વી નોચ માટે if you will simplify this equation, so આપણે previously since it's gravitational constant and tan theta ની value, so you can just simplify and make it a constant, right? So અહીંયા આગળ એ લોકો એ જ કર્યું છે. Q actual is 14.17, right? So this is in normal SI unit. જો આપણે સેન્ટીમીટરમાં કન્વર્ટ કરીશું, so that considering coefficient discharge of 0.6, so actual flow rate આવશે 14.17 h raised to 2.5. okay, so same h है, just put this value. So actual flow rate जाओ 2384.63, right? हाँ 8464 down. So now you know theoretical flow rate મળી ગયો rectangular notch માંથી, અને આપણે V notch પરથી actual flow rate consider કરી લીધો. Then we can compute the coefficient of discharge for rectangular notch. So that will be theoretical divided by actual flow rate. So this comes around 0.58. You can check 0.5845. Right? So this is how it is done. So basically previous experiment માં શું કર્યું, V notch માં we computed actual theoretical flow rate through the wear height, and then actual flow rate માટે આપણે શું કર્યું કે ટેન્કમાં 10 સેન્ટીમીટર હાઇટ ભરવા માટે કેટલો ટાઈમ લાગે એના પરથી એકચ્યુઅલ ફ્લો રેટ કમ્પ્યુટ કર્યો. રેક્ટેન્ગ્યુલર નોચમાં રેક્ટેન્ગ્યુલર નોચ માટે થિયોરેટિકલ ફ્લો રેટ આપણે વિયર હાઇટ પરથી કમ્પ્યુટ કર્યું. બટ ઇન્સ્ટેડ ઓફ કમ્પ્યુટિંગ actual flow rate by collecting sample in a tank આપણે વી નોચનો યુઝ કર્યો, રાઈટ. ઇન્સ્ટેડ ઓફ દેટ ડાયરેક્ટ સેમ વી નોચ જેવું સેમ્પલ આપણે રાખ્યું હોત સેમ્પલ કલેક્ટર અને એમાંથી એકચ્યુઅલ ફ્લો રેટ કર્યો હોત તો બી પોસિબલ છે, રાઈટ. સો આ એમનું સેટઅપ છે, એ રીતે અકોર્ડિંગલી એમને ડિઝાઇન કર્યું છે. સો બેસિકલી વી નોચ પરથી આપણે એકચ્યુઅલ ફ્લો રેટ ફાઇન્ડ કરી લીધો અને થિયોરેટિકલ ફ્લો રેટ પરથી કમ્પેર કરીને રેક્ટેન્ગ્યુલર નોચનું સીડી ફાઇન્ડ કર્યું, રાઈટ. So this is your experiment part. Further, you can do it multiple times to average out the value. Okay, so multiple times repeat करो and the CD ની value average कर लो अलग अलग flow rate पर, right? So this was the experiment. So understanding flow through V notch and rectangular notch, right? Flow through notches, and then we computed the coefficient of discharge for both V notch and rectangular notch and calculated its formula also, right. So this was for today's class. If you have further any doubt, you can ask. I think Jatin is laughing or celebrating, whatever. So if you have any doubt, just say it. If not, then I will end today's lecture here. I will upload the material on Drive and this lecture video will be uploaded on YouTube. Okay. Thank you for joining.